Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem merge intervals. In this problem, we are given an array of intervals where each element in this array represents an interval containing two integers, start of the interval and end of the interval. The task is to merge all the overlapping intervals and return the array of non-overlapping intervals that cover all the intervals in the input. That means the output must contain intervals which are independent of each other. Let's see the input and output format. We'll be given an array of intervals containing n intervals, while we have to return an array of intervals containing independent intervals after I have combined the overlapping intervals. Let's better understand the problem statement using an example. So this is input sample. In this input we are given four intervals. First interval is from 1 to 3, second is from 2 to 6, third is from 8 to 10, and 4 is from 15 to 8. The output would be 1, 6. Why? Because I can see that the first interval, that is 1, 3 and 2, 6, they are overlapping here. Since they are overlapping, I can replace these two intervals with one interval which starts from 1 and ends at 6, and that's what I am doing. I replace these two intervals and I put a larger interval 1, 6 which covers both of these intervals. Then 8, 10 is already an independent interval, as there is no other interval which is overlapping this interval. So I put it in my answer array as it is. Then I have my final interval starting from 15 ending at 18. It is also independent, hence I put it as it is in my answer array. So this is my answer array. It contains three intervals which are independent of each other, and I will return this array from my function. Let's see how we can solve this problem. The first approach to solve this problem is to sort the intervals. Why do we have to sort the intervals? Because if we sort the intervals by the starting time, then the overlapping intervals will be adjacent to each other. For instance, in this case, we can see that after I sort this set of intervals, the continuous intervals will be adjacent to each other. 1, 3 and 2, 6 will be adjacent to each other, as these intervals here are overlapping intervals. So we get our overlapping intervals adjacent to each other so that it becomes easy to combine them. Then we take three pointers, a pointer L which initially points to the first element of the first interval, a pointer R which initially points to the second element of the first interval, and a pointer I which iterates over the intervals starting from the second interval. Then what we have to check is if the first element of the interval on which I am standing, that is this, lies in the range which is represented by this L and R. So I check if 2 lies in the range 1, 3. Yes, it does lie. Therefore, I can combine these intervals. How would I combine? Simply, the new interval will have the starting point as 1 and the ending point as 6. So I will combine this interval into 1 and 6. So I will combine this interval into 1 and 6. Because you can see that these are overlapping, then this portion can be combined to give a single interval starting from 1 ending at 6. Then this becomes my previous interval, that is 1, 6, and the current interval on which I am standing is 8, 10. I will again check if 8 lies within the previous interval 1, 6, and the answer is no. 8 lies ahead of 6. Therefore this interval must be independent because the ending time is greater than the starting time. Hence I conclude that this is an independent interval, so I push this interval into my resultant array as it is. Then the previous interval becomes this interval, that is 8, 10 here, and I'm standing on the next interval which is 15, 18. I'll check again if 15 lies within the previous interval, and the answer is no, it does not lies within the previous interval, hence this is an independent interval. So I push this interval as it is in my resultant array. And that's all. I have entered my set of intervals, and this is the resultant set of intervals that I get, which is the answer for this input set. I hope you got the idea what we are doing here. Let's see the implementation of the approach which I explained here. Okay, so this is the implementation of the merge intervals function. It takes in the intervals as argument and calculates the size of the intervals, sort the intervals by the starting time, and initializes two pointers L and R with the first interval, which represents the previous interval that we are standing. This is an array, two-dimensional array, which will store the final intervals. Then I'll iterate over the intervals starting from the second interval, and I will check if the starting point of the interval on which I am standing, this I is pointing to, is greater than R. That means if this interval is ahead of this interval, if this is the case, then we know that this interval is independent interval. Hence I push it in the resultant array as it is, and I update my previous interval with this interval. Otherwise, if the starting point of the current interval lies within the previous interval, then I can combine this interval LR with the current interval and update the ending point with the ending point of this interval, ith interval. That's all. Finally, I return my resultant array. So this is the implementation for the merge intervals function. Let's discuss the time and space complexity for this solution. You can see that we are sorting the intervals. The sorting algorithm takes n log n time complexity, and we are iterating over the intervals once, which takes in linear time complexity, giving me an overall time complexity of n log n. And the space complexity is constant because we are not using any extra space. We are not considering the array which we are using to store the final intervals. And let's see the implementation for this approach. So this is the merge intervals function, which takes in intervals array and returns an intervals array, which are non-overlapping intervals. I'll calculate the size of the intervals array. Then I will initialize my previous interval. I'll declare an array to store the resultant intervals. Then I will iterate over the intervals starting from the second interval, and in the first case I will check if the current interval on which I am standing lies ahead of the ending point of the previous interval. If this is the case, treat it as an independent interval and push it into the resultant array while updating my previous interval with this interval. Otherwise, the case is we simply expand the current interval and update the ending point of my previous interval. Finally, I push final interval into the array and I return the result right from here. So this is the implementation in C++. Let's see the implementation in Java. So this is the implementation in Java language, while this is the implementation in Python language. I've attached these codes in the description, so make sure to check it out. There's another approach to solve this problem, that is connected components. We'll discuss this approach in the next video, so stay tuned for that. And that's all for this video. If you liked it, then make sure to spread the word, and I will see you in the next